All right, here's the View Components sample project, and I have this open in Visual Studio 2015. So I'll go ahead and run this so you can see what it does. So basically, this is a to-do application. And so it has a list of to-do items, along with some priorities. As soon as it loads, anyway. There we go. All right, so this is a static list. It looks like I have a checkbox, but it's all disabled. It's really not an interactive kind of application. But the idea here is that I have a view component down here that is going to list the priority items. And in this case, there's two criteria. One is that they're not yet done, and that they have a priority of at least 2. So 1 is a higher priority, 5 is the lowest priority. Okay, so the ones that meet that criteria are task 2 here. This one doesn't because it's too low a priority. That has too low a priority. Here's another one that meets the criteria, task 6. Too low a priority, too low a priority. And then of course all of these 3 are already done. So what the view component is doing is it is condensing information, summarizing information, analyzing information, and then displaying the data. So a very common kind of a use for a view component. But you can also display static data, and you can do pretty much anything that you want. Okay, so I'll cancel out of this. Now, one thing about the organization of this is that in this project, all of the view components, there's just one, but the view components are within this view components folder. That's not required by any stretch. There's nothing magical about that view components folder. You could name it Floyd. You also don't have to put all of the view components within a project in the same location. Anywhere that you can put code that's compiled into the application, feel free to put your view components there. But this is a nice convention, keeps it organized. It makes it very easy to find the view components. And of course, you can put view components in a separate assembly as well if you're using them with multiple applications. You have all that usual kind of goodness in an object-oriented environment. All right, so let's take a look at the code behind this view component. So here's the view component class. Now keep in mind, there's 3 different ways to identify to ASP.NET Core, to the runtime, that this is a view component. One is that you derive from view component. And again, this is probably going to be the most likely way that you use view components. Second way is I could put an attribute onto the class, and it's a view component attribute, or derive from a class with that view component attribute. And then finally, can create a class where the name ends with the suffix view component. So in fact, that's what happens here. So I'm really kind of doubly identifying this as a view component. This is still a nice convention. It identifies it, makes it very easy to see if I'm looking at objects that are reference and class and object graphs and so forth. I can see that this class is a view component. It makes it very unambiguous. I don't have to go and find the code for priority list to find out what kind of an object this is. Okay, so that's a good convention to use too. But keep in mind that if I just use this convention, I didn't inherit from view component, then I wouldn't get all of the features that are a part of the view component infrastructure that are provided by that class. For example, this view method here is a property of that view component class. So I wouldn't have the benefit of being able to return and call the view method there. Okay, and again, like controllers, view components have to be public, so it's public here. Non-nested, it's not a nested class, it's at its own level within the namespace, and a non-abstract class. Okay, and then finally, keep in mind that the name of the view component that I'm going to use elsewhere within the application is just priority list because the name of it is that without the view component suffix. All right, another nice thing about view components is that it supports constructor dependency injection, and it also then doesn't take part in the controller lifecycle. Instead, it's specifically invoked, and I'll show you how to do that a little bit later. But as far as dependency injection goes, notice that I have the constructor here, and I'm injecting an entity framework object context right there. Okay, so let's take a quick look at those entity framework objects. Those are all here within the models. Here's the to-do context. As you can see, it's very simple. It inherits from DB context, which is commonly what you're going to want to do with Entity Framework Core. In fact, pretty much always will do with Entity Framework Core, less so with Entity Framework 6.x necessarily. And then you have a constructor, calls the base options, and then in this case, I have a single collection of to-do items. And the name of the class here is to-do item, and I'm just calling that to-do here within the to-do context. This is also a very simple class, just has an ID, name, priority, and whether or not the class is done. Very simple sort of data that I need for the functional application. And then another thing that's kind of interesting here is the seed data. I need some kind of data. It's all randomly generated each time. But I can create this seed data class, and this is one of many ways to do this. And I'm actually in the second view component example I'm going to show you. I'm going to do this in a different way. But in this case, I have an initialize method. I'm injecting the service provider that gives me access to the to-do context that is available within the application. So this is all kind of hooking into the to-do context that's defined within the startup class and is available for dependency injection. Here I'm explicitly getting that service. It's another way of getting access to a service within the application. And then if the database property of that is null, I'm going to throw an exception. It should never be null. So that's a problem. And then otherwise, I'm going to add new to-do items to that database and then save the changes. So it's just a way of initializing data. In a real application, I'm probably going to have a service, and that's the technique that I use in the next example, to read the data from a database, although I'm not directly reading from a database, but I'll explain all that when we look at the second view component example. And so this is going to populate that context object if there's no data yet. Oh, no, that's if the database is null. It's going to populate this object with the database with this data that produces all of those to-do items. Okay, let me emphasize again, it's not reading from a database, it's populating the contents of the database. If the database object is null, that's a separate problem, that's an exception. It means something happened with the initialization of that context provider. So then save the changes, and then it's available within the application. So let me go look at startup to see how all that's wired up. So here's where, in the configure services, I'm calling the add DB context method of that iService collection in order to add an Entity Framework context. It's using that to-do context that I just showed you. And in this case, it's using an in-memory database. So this is essentially one of the providers of Entity Framework Core, just like the SQL Server provider or the MySQL provider or various other providers that are available. This is a really nice feature that makes it easy for development and testing. I can write all the code, treat it as though it's a regular Entity Framework database that's persisted someplace, but it's just in memory, and it's great. I don't have to worry about creating a database, keeping it in sync with the as I make changes to the models and so forth. It's just being used in memory. So really a pretty nice slick feature. I have found uses for it in real applications when I have transient data that isn't persisted anywhere. Maybe it's being generated on the fly or something like that before I do something else for it. But generally it's a provider for any framework core that you use in development and testing. Okay, so this makes that to-do context available as Entity Framework. And then down here in the configure method, which again is called once when the application is instantiating or is initializing, I call that seeddata.initialize, that method that I just showed you that comes in and adds all of that data to the database. Okay, so that's how all that works, and that's how the database gets some initial seed data that it can use. Okay, so let's go back to the view component. So we're injecting that context in here. It's already loaded with data, so it's all set, and we're saving it to the this DB, this read-only to-do context. I'm not going to be updating the data, so make it read-only, make it a little bit more efficient. Okay, and then here's that invoke async method. So a view component defines its logic within an invoke async method. And this typically is going to return an iViewComponent result. And because it's async, I have to wrap it in a task there. Now, the parameters here come directly from the invocation of the view component, not from model binding through an HTTP request. That's an important difference between action methods and view components. Okay, and partially that's because view components never directly handles an HTTP request. Now, typically, a view component is going to initialize a model and then pass it to a view. And that's what's happening here. I'm calling the getItemsAsync method that's here. I'll talk about in just a moment. I'm passing in the max priority and the due date. So this is how I was able to set that I want only to-do items of priority 2 and higher, and whether or not I want to include any is-done tasks. And so these are parameters, and so I can vary that. And so depending upon how I invoke this view component, it's going to return different results. Okay, so that becomes the model that I pass then to the view. This is optional, just like it is with action methods within controllers. You don't have to pass a model, but this is a way to provide data to that model that then is rendered in that chunk of HTML that's displayed on the page. All right, then getItemsAsync is basically just a wrapper around a query using the entity framework, the object context. And here I'm going to specify that isDone is equal to the value that I'm passing in. And then the priority is less than or equal to the maximum priority. Keep in mind that 1 is the highest priority task, 2 is lower priority, 3 and so forth, lower priority yet. So it's just a where query here that filters what is returned from this view and displayed within the view. Okay, so the next thing you need to look at is the view that's associated with this view component. For that, I need to come here into Views, and it's under Shared, Components, Priority List. Remember, it needs to be the View Shared Components Priority List, the name of the view component. And then I'm using the default view here, default.cshtml. I could have put this within the to-do controller view here, but because this is going to apply to all controllers, obviously just one controller in this simple application, I'm putting it in what really is probably going to be the most common location for this. Okay, so I'll go ahead and open that up, and as you can see, it's a very simple kind of a view, very similar to a view that you would create for an action method. I define that the model is an IEnumerable view component sample models to-do item, and then it's going to loop through all of the to-do items within that model and just display them out as line items. Okay, so the view itself is very simple. Just keep in mind too that you don't have to use the default name of the view. It can be default.cshtml or it can be Floyd if you want it. But if you change it from default, you have to specify the name of it when you invoke the view. Okay, then the last piece here is to look at index.cshtml. So the first thing this does is it displays all of the items in that list. Okay, so remember when I ran the page, it listed all of the to-do items, whether they were done or not, and all the priorities. So that's the first part of this page. And then here's the invocation of the view component. So this shows the syntax. It's asynchronous, so you have to use the await, and then component, which is a property of the view, dot invoke async, the name of that component, and keep in mind that I can use the name of and pass that in as an object name instead of as a string, and that gives you strong typing. And then I'm newing up an anonymous object and passing it the values of the parameters that are defined within the view component, which has disappeared off my screen. Let me hide that, see a little bit better. So I have max priority and isDone, and so I have to use those names as the properties of that anonymous object. Okay, last thing to look at is the to-do controller and the index method. And notice that here there's nothing that indicates that there's a view component that's used within the page. It's invoked from within the index view. And another thing to keep in mind is that this model is not used by the view component. The view component has its own data. It's not inherited. So that's a difference between earlier classic ASP.NET reusable components. Okay, so that's how the application is used together, how the view component is defined, and how it's invoked. And if I run it one more time, you can see, now that you understand how it all works, you can see that I have all of the to-do items once it loads. There are all the to-do items, and then there's the view component. And because I'm invoking it using the parameter values that I did, I'm getting just those 2 priority items. And in fact, to make that painfully clear, I'm invoking it with a max priority of 2 and an isDone value equal to false, and so that's why I got those to-do items. Okay, now one other thing to look at here, I have a second action method here that says index VC. And this is showing how you can invoke a view component directly from within an action method. You just return, it's a regular iAction result, just like probably most action methods. And so you return the view component, and you pass in that same information, the name of the view component. You can use the name of operator there and not use a string, so you have strong typing. And then another anonymous object. But here, what it's doing is it's using different values for those parameters. And so I'm setting the maximum priority of 3 and isDone equal to false. All right, so I'll run the application one more time. But this time, I'll come up here and do to-do and index VC. All right, so now the view component is just being displayed by itself. I set the maximum priority to 3, and so now I'm getting some additional tasks in there. So there you have a pretty simple but non-trivial example of a view component, and you can see how it all comes together within the application.